Hi, this is the current version of my robot legs, which I've been working on for several months. Previous versions of the legs, I used a lot of parts made with 3D printing, ABS. I kept breaking things, so the current version, I've built all the structural parts out of scrap aluminum. The parts are drawn in Autodesk Inventor, then I post-process the Inventor parts and I machine them with a Tormac CNC 770M. The upper and lower legs members are still the same. I'm using aluminum 2020 for the main structure. Sensor holders, encoder holders, and the battery case and stuff are still 3D printed, and I use a Maker Gear M3 printer for that. Here I'm showing views right out of Autodesk Inventor of the various parts of the robot legs. Here on this back view you can actually see the case that holds the 3 lithium ion cells. The lithium ion cells are 3.7 volts each, so it gives me about 10 or 11 volts for the voltage for the motors and running everything. So these are views of the various parts of the robot, and I've labeled them so you can see what the parts are. I figure you can always stop it if you want to actually look at it closer. The seat motor, or the motors, 4 of the motors are out of car seats, and if you look carefully on some of these views you can actually see a Acme spline, and that spline is actually out of a car seat, and it's what moves the seat back and forth. So I use them on the knees and on the ankles to do pitch. So here I'm showing, I'm going to balance on the left leg, and the right knee goes up, and then also the right ankle pitches up. So I still use a winch from my ceiling to pick up and lower the robot legs so I can work on them, change the motors or whatever I want to do. But when I'm walking right now, when I'm taking steps or balancing or something, I just have the strap real loose, so if it falls over it would catch it, but it's not actually supporting the robot. So here I'm going to balance on the right leg, and if you notice the left knee will bend up, and the left ankle is also pitching up. And then when it comes back down, now the right ankle rotates back to put it back on both feet. And if you look closely at the top, you'll get another chance here. When you look at, here we are again. I'm actually going to take a step. So the light that's on there is actually an Adafruit NeoPixel ring, and I have an inertial measurement unit at the top on the electronics panel, and I'm actually using roll and pitch. So I actually use the ankles and I roll either 8 degrees left or right on the ankle when I want to stand on whichever foot, and then pitch I'm actually using to keep the electronic assembly on the top platform so it stays vertical. So if you notice at the end of a step, I'll wait for it to finish this right foot. Okay, so right here it actually looks at pitch and from the IMU and adjusted the electronic portion of the robot up on top above the hip platform, so it was vertical again. So the 10 or 11 volts from the batteries are actually, I have a DC to DC inverter, and that's that right thing that's flashing up in the top right corner, and it's actually taking the 10 or 11 volts and moving it to 5 volts. So right now everything's being controlled by a Arduino Mega, which I kind of think is an I/O processor. I also have a Raspberry Pi on here that I'm not using yet, and the Raspberry Pi is, I hope, will make more intelligent decisions. So I have angle sensors on all of the pivot points, so I can read the angles, like right there when the knee goes up. And I can also, since the robot motor controller boards support encoders, I can tell it to go to a certain position and stop. So I'm having a lot of fun building these legs, and this is the 4th version I've worked on. Thanks for watching.